A uniform string of length 20 meter is suspended from a rigid support. A short wave pulse is introduced at the lowest end. It starts moving up the string. The time taken to reach the support is, taking g as 10 meter per second square. So this question is based directly on the formula. So we have to find out the wave velocity, and wave velocity we can easily relate with the time. So we start from the wave velocity. We know that our wave velocity, which is represented as v, is equal to our square root of t divided by mu, where t is the tension and mu is the mass per unit length. So we have to find out the tension. So in this case, what we do, we assume that, let me draw an approximate diagram. Suppose this is a support and this is string, and here we assume a point P which is at a distance of x from the bottom side of the, that's the free end of this string. So we are going to find out the tension at this point P. So let us say the tension at point P, tension at point P which is at point P at a distance x from the lower end, from the lower means free end of the string. So the tension, we can write that tension will be obviously associated with the weight, and we assume that the weight of the string up till the point P is, let us suppose, is represented as mp. So we say this tension is due to weight of the string below point P, below point P, and we assume that its mass is mp. So we can write that our tension will be equal to mp multiplied by g, and this mass we can write in the form of mu multiplied by x, and this will be multiplied by g. So now we can write that the formula for the velocity, we found out the tension, so we can say the velocity will be now equal to square root of mu x multiplied by g and divided by mu, and here mu and mu cancels out, so we get that velocity is equal to square root of g multiplied by x. And we also know the relationship between the velocity and displacement distance x is our V is equal to dx by dt. So just above this point P, we consider a small thickness of the rope, or suppose we can say small length of the rope, and that length is assumed to be dx. So we say for a small segment of the rope, for a small segment of rope dx, the time taken by the pulse is dt. The time taken by the pulse which is being generated is suppose given as dt. So we can write that our dt will be equal to dx divided by v, because v is dx by dt, and we substitute value of v. V is our square root of gx, and this comes our dx. So we have to find out the time taken by the pulse for the entire length, and this entire length is given as L. So L is the length of this entire string. So integrate it from 0 up till L. Then we are going to get the time period. So we write for entire length L, T is equal to integration of dt, which is integration of 0 to L, and we get 1 upon square root of gx multiplied by dx, and length is given us as 20, so we write 0 to 20, and this becomes 1 upon square root of gx, and this is our dx out of the simple integration. So this gives us 1 upon square root of g, and here we have 2 square root of x, 0 to 20. G we are supposed to be taken as 10, so this becomes square root of 10 multiplied by 2, and this becomes square root of 20, and square root of 20 we can write it as 10 multiplied by 2, so we can say t is equal to 1 upon square root of 10 multiplied by 2, and this becomes square root of 2 multiplied by square root of 10, and 10 goes with 10, so this gives us is equal to 2 square root of 2 seconds. So we can say that t is equal to 2 square root of 2 seconds. So this is the amount of time taken by the pulse to travel the length of 20 meters. So the option that are available to us, option number C, is the correct option. So you can say option C is correct. So this completes the question. Thank you.